Time varying fields, Poynting theorem, series on electromagnetic field theory, lecture number 3.50. Dynamic fields or time varying fields carry certain amount of power flow. This power flow is called electromagnetic radiation. The functioning of antennas is based on electromagnetic radiation. Poynting theorem, it is able to provide a tool by which one can compute the power flow that is existing in the dynamic fields. In the present session, our focus is on Poynting theorem and the tool that is Poynting vector. It provides to compute the power flow. What is Poynting theorem? Poynting theorem is basically energy conservation principle applied to electromagnetic field. What is energy conservation principle? Energy can neither be created nor destroyed. Only transformation can be done from one form to another form. This is energy conservation principle, and it can be applied to any type of energy. It may be mechanical energy, it may be electrical energy, or it may be some other type of energy. It can be applied even to electromagnetic fields. When it is applied to electromagnetic fields, the resultant principle is Poynting theorem. It is in the name of Henry Poynting. He was an English physicist. He was a professor in physics at University of Birmingham. One of the important characteristics of a traveling wave, EM wave 2, is its ability to carry energy. As already mentioned, this flow of energy or flow of power is called radiation. Without this capacity, many of the important applications of EM waves could not have been realized. For example, if flow is not there, antennas are not possible. If antennas are not possible, then wireless communications not at all realizable. This theorem is in fact a statement useful to examine power and energy relations in EM fields and waves, and can be derived from Maxwell's equations. Poynting theorem has two forms: integral and differential, and in each time domain, phasor domain. In integral form, time domain, phasor domain. In differential form also, time domain and phasor domain. The integral form time domain theorem states, first we consider this one, the integral form time domain form, and we consider, it states the net power flowing out of a closed surface S enclosing a volume V is equal to net sum of time rate of decrease in the energy stored, the power dissipated, and the power output of the source within the volume. Mathematically, it can be stated as closed surface integral E cross H dot dA equal to minus dou by dou t volume integral epsilon E square by 2 plus mu H square by 2 d tau minus volume integral sigma E square d tau plus volume integral E dot Js d tau. Here, what is E? Electric field intensity. What is H? Magnetic field intensity. See, we are considering dynamic fields. In dynamic fields, electric field exists, magnetic field exists. E and H are vectors pertaining to electric field and magnetic field in the time varying fields. Dou by dou t, time variation. Epsilon E square. E square is, E is amplitude E square by 2 plus mu H square by 2. One can notice, or one can recollect, this epsilon E square, this mu H square. We come across these factors or these products in static fields too. Epsilon E square there while computing energy density in the electric field, we come across this one. Similarly, mu H square by 2. This thing, mu H square, we come across while computing energy in the magnetic fields. So this particular term, first term, it has right hand side, we have three terms. First term pertains to, we can say it pertains to energies that are stored in the fields, energy storage, minus sigma E square. This sigma E square is Joule's law. It tells how much energy is converted into heat, Joule's law. When it comes to third one, E dot Js. E, electric field, J, current from the source. This product gives how much power is being given out by the source. Right. Left hand side we have one closed surface integral. So this closed surface integral, it is equated to stored energies, power dissipated and power generated by the source. With this understanding, let us move further. According to this theorem, the vector E cross H, this vector is called Poynting vector. Here you can find Poynting vector. At any point in the field gives a measure of power flow per unit area at that point. Here an interpretation of various terms is given. This equation is from the previous slide. Left hand side it is closed surface integral. Right hand side we have three terms. See, this one, first one can be recognized as something related to energy storage in the fields. Dou by dou t is there, therefore it can be interpreted. First term on the right hand side can be interpreted as rate of decrease of stored energy. Minus sign is there, therefore it is decrease. Rate, dou by dou t is there, therefore rate is, we can consider it as a rate. Then epsilon is square by 2, mu h square by 2. These are energy densities, stored energy densities. Therefore, all put together we can say rate of decrease of stored energy. First term. When it comes to second term, this is Joule's law. So we can easily understand it is power dissipated. Now E dot Gs, it is like Vi, similar to Vi. Let us suppose across a source voltage is V and current out of the source is I. Then power that is generated by the source is Vi. Of course, this is circuit theory relation. When it comes to field theory, it becomes E dot Js. So we can easily understand that it is power generated, or we can interpret this particular term as power generated. The first term is decrease of stored energy, second term is power dissipated, third term is power generated. With this understanding, when we apply energy conservation principle to this situation, it gives us an interpretation of the term that is on the left hand side as power flowing out. Here we considered a closed surface. This is closed surface. This is a volume. So first term on the left hand side says these three terms, after taking their sign into account, the first or the only term that is on the left hand side says that this is power flowing out of the surface, out from the from inside to outside. How much power is flowing out? Power flowing out. E cross H is power flowing out. Of course, after integration, it becomes total power that is flowing out. E cross H per unit area, integration over the entire surface makes it total power flowing out. Now, how that particular relation has been derived? One way is by using Maxwell's equations. Apply E dot over Maxwell Ampere's law and subtract it from Faraday's law after applying H dot. It results in, what he says is, subtract E dot applied over Ampere's law. E dot applied over Ampere's law from Faraday's law after applying H dot del cross. Then it results minus epsilon E dot dou E by dou T minus mu H dot dou H by dou T minus E dot J. So this H dot H, it is replaced by, or E dot E, H dot H. Some manipulation can be done, resulting in minus epsilon by 2 dou E square by dou T minus mu by 2 dou H square by dou T minus E dot J. Now, the current, concentrate on the current. J can have a dissipative component Jc, which is equal to sigma E, and a source component Js. The total current J can be written, considering this aspect, can be written as Jc minus Js. It results in E dot J equal to E dot Jc minus Js, but Jc is sigma E, Ohm's law minus Js, so it results in sigma E square minus E dot Js. Using a vector identity, the left hand side can be replaced. He is talking about this part. This part can be replaced by del dot E cross H. After incorporating these two modifications involving E dot J and left hand side, one can write del dot E cross H equal to minus epsilon by 2 dou E square by dou T minus mu by 2 dou H square by dou T minus sigma E square plus plus E dot Js. This is the relation. It is Poynting theorem. It is said to be in point form. It is differential form. Differentiation is there. Del is there in this relation, in this equation. That's why it is called differential form or Poynting form. It is Poynting theorem. In point form, to obtain integral form, divergence theorem has to be applied after performing integration over the volume V. It results in the relation or theorem which was given in the previous slide. For example, see, this is the integral relation, whereas this one is differential relation. Now we spend some time on another form of Poynting theorem. It is called complex Poynting theorem. Poynting theorem is also available in phasor form. Then it is called complex Poynting theorem. The integral form, phasor domain theorem, states the total complex power fed into a volume is equal to the algebraic sum of active power, reactive power, power output of the source. Active power dissipated as heat, reactive power proportional to the difference between time average magnetic and electric energies stored in the volume plus power output of the source located within the volume. Mathematically, it can be expressed. This is integral form. Integration is there, that's why it is integral form. Here, all field quantities are phasors. You can find time nowhere in this expression. All fields are phasors, complex quantities. Now, on left hand side, you can find single term E cross H complex conjugate. Half is there. Integration is over closed surface. Now, first term on the right hand side is sigma E square. So it is Joule's law, power dissipated. Last term is E dot Js. Therefore, it is power generated by the or created by the or given out by the source. So this term, which is in the middle, it must be energy stored. It must pertain to energy storage in the fields. Let us move further. Some interpretation can be given for each term. See, the importance of energy conservation principle here in Poynting theorem is it is able to give a meaning to certain terms. For example, E cross H. Meaning to E cross H is given by energy conservation principle. If that principle is not there, E cross H becomes almost meaningless. Right. In the above theorem, above statement or above expression, P is half E cross H conjugate. This P is called complex Poynting vector. The name is there. E cross H is Poynting vector, but that is in time domain. Now we are in phasor domain. In phasor domain, half E cross H conjugate is Poynting vector. Half sigma E square is dissipative power. Time average dissipative power. 1/4 mu H square, which is sometimes indicated by omega Wm, is called time averaged magnetic stored energy. 1/4 of epsilon E square indicated by We, it is actually time averaged electric stored energy. And half E dot Js is complex power output of the source. Here one can find half. Maybe you are wondering why this half, 1/4, 1/4, 1/4. The reason is here fields are amplitudes. If you want average value from amplitude, you have to divide the amplitude with 1 by root 2. Two fields are there. EH is there. 1 by root 2 into 1 by root 2 makes half. Similarly, E square is there. 1 by root 2 square is 1 by 2. Here, H square is there. 1 by root 2 into 1 by root 2 becomes half. Already 1/2 exists. Energy density in magnetic field is half mu H square. Already 1/2 is there. Another half due to H being phasor. Similarly, here also 1/4 epsilon E square. You can understand why it is 1/4, why it is half here. Now, energy. Energy in the field from Poynting theorem only. From the statement, one can understand it is epsilon E square by 4 plus mu H square by 4, which is equal to half epsilon E square by 2 plus mu H square by 2. So what exactly here he is trying to tell? Poynting theorem, we know energy storage in static fields. But Poynting theorem says, Poynting theorem tells, Poynting theorem gives some kind of proof for the energy storage in dynamic fields. As far as static fields are concerned, it is derived. From basics, it is derived. From the definition of energy, work and all that, things are derived. But when it comes to dynamic fields, proof for energy storage or expression and also expression for energy storage in the fields, it is given by Poynting theorem. It says average energy is given by epsilon E square by 4 plus mu H square by 4. Of course, a half can be brought out. This part is called electrical energy. This part is called magnetic energy. One more thing here, I want to state that average electrical energy can be found equal to average magnetic energy. So energy storage as far as dynamic fields are concerned is half of it is in the form of electrical energy, half of it is in the form of magnetic energy. Now, how this phasor form principle Poynting theorem is derived, the procedure is explained here. Apply E dot over conjugate of Ampere's law and subtract it from Faraday's law after applying H conjugate dot. It results in this particular H conjugate dot del cross E minus E dot curl H conjugate. Now it results minus E dot J conjugate minus J omega epsilon E dot minus J omega mu H conjugate dot H. Here one point before going further, in the previous, in time domain Poynting, derivation of time domain Poynting theorem also we use Maxwell's equations. So here also we are using Maxwell's equations. In procedure is also almost same. The basic difference is there we used time domain Maxwell's equations, time domain Ampere's law, time domain Faraday's law, whereas here we are using phasor domain Ampere's law and phasor domain Faraday's law. That difference is to be noted. Procedure is same, laws are same, the process is same, everything is same. Only thing is there it is time domain equations, here we are using phasor domain equations. A little bit, of course, this particular left hand side thing can be written as del dot E cross H conjugate, and after manipulation, a little bit of manipulation, you will be getting like minus E dot J conjugate plus J omega epsilon E square minus mu H square. However, as current can have a dissipative component, source component, total current J can be written. This is what we have done in case of time domain theorem derivation also. Same thing here we are doing. J equal to Jc minus Js, which is sigma E minus Js. Therefore, minus E dot J conjugate is E dot Js minus sigma E square. Of course, this is your Joule's law for power dissipation. So this ultimately what you have is half del dot E cross H conjugate equal to minus half sigma E square minus half J omega mu H square minus epsilon E square plus half E dot Js conjugate. This relation, this particular relation you can see for yourself, it involves differentiation. Where is differentiation? This is differential. Del is differential operator. So this relation is said to be Poynting theorem in point form. To obtain integral form, of course, divergence theorem has to be applied after performing integration for the volume V. In general, this theorem gives the power flow relations associated with dynamic fields in any volume in terms of EM quantities, E and H. It also gives net flow of power out of given volume through its enclosing surface. It is able to give an expression for power flow per unit area, Poynting vector. It is called Poynting vector, that E cross H. In this case also, as already mentioned, similar to what we have done in case of time domain Poynting theorem, in case of this phasor domain theorem also, you can apply energy conservation principle and derive a meaning for the left hand term. The meaning which you get is half E cross H conjugate gives you power flow per unit area. So in either case, Poynting vector gives you amount of power flow. This vector was co-invented by Oliver Heaviside. Oliver Heaviside, here one point is required to be told. Oliver Heaviside is as great as James Clerk Maxwell, or I can say he is next only to James Clerk Maxwell as far as his contribution to the development of Maxwell's equations are concerned. Not only that, in other areas also, his contribution is significant. So Heaviside is not an ordinary to be neglected, or one can be neglected, somebody who can be neglected. No, he is a great scientist, great inventor with a lot of contribution to the development of field theory and all that. Before Heaviside, these laws, so-called Maxwell's equations, they were around 12 in number. After this man, they become 4. So he is able to contract them, or he is able to put them, that many number, into smaller number. So his contribution is significant. It was invented by Heaviside and Nikolai Yumov, a Russian physicist, independently for dynamic fields. Its direction is same as direction of flow of power. So Poynting vector is an outcome. What I am calling it as a tool. Poynting vector is a tool. This tool is useful for us in computing power that is flowing. The Russian physicist, independently for dynamic fields, its direction is same as direction of power flow of power. Poynting theorem also gives an expression for energy density and also stored energy in dynamic fields. So here 2 points are to be noted as far as Poynting theorem is concerned. What are they? First one, Poynting theorem gives an expression for power flow that exists in the dynamic fields. First point. Second point, Poynting theorem is also able to give an expression for energy stored in the dynamic fields. Of course, these expressions, energy storage expressions, they are found similar to the energy stored expressions that are derived while we are discussing static fields. Okay, this is all for today to share with you. Thank you.